Welcome back. Until now, we were using a RowMapper called bean property RowMapper. So in all the steps, we made use of this RowMapper to map the results of the query to the bean, to the person bean. However, the thing is you can even define your own custom RowMapper. So if the data which is coming back from the table is of a different structure compared to your bean, for example, if the column names don't really match, so if the column name does not match with the field name in person, so in those kind of situations you'd want to create your own RowMapper. Let's define a simple RowMapper for this person class. The way you can define a RowMapper is by implementing a simple interface which is called RowMapper. So I'll say RowMapper of which bean you'd want to map the values to. Now I can define a person RowMapper implements RowMapper. I'm creating an inner class here because I would want this to be used only inside the person JDBC DAO. I would import the RowMapper interface or Spring Framework JDBC. That's the one which we are looking for. You need to implement a specific method. So I do a control1 or command1 in here, add unimplemented methods. This is the specific thing that we would need to implement. So what I can do here is person is equal to new person. Oops, typo in here. What we would need to do is to return a person back. So now this code compiles. What the RowMapper interface defines is how should you map one specific row. One row in the result set, how do you want to map it to the person? The number of the row is available, but most of the times you don't really make use of the row number. All that we do is get the value from the result set dot get int, and then we can say the name of the column. So I can say get int id. Where do I want to take that value and put it in? Person dot set id. Similar to this, we can map all the other columns manually. You can say set name. However, to be able to set the name, you need to get a string call name. Right? Name is a string. And the other one is location. So let's do that. Location. And this is also a string called location. And the last one is get date, right? So target underscore date. In the database, we have defined it as a timestamp. So what we'll do is get timestamp. And over here, we would want to set it to which field? To birth date. Make sure that you're using a small s, it's not a capital S. So timestamp is one word. So I'm using a timestamp to get the target date and set the birth date based on it. That's it. You have your person RowMapper ready. And over here, now, instead of using this bean property RowMapper, what I can start doing is use person RowMapper. So I can say person RowMapper. For the person object, it does not make a huge difference because the exact names match. So ID is ID, name is name, location is location. Actually, this should have been birth date. Where did I get the target date from? Okay, birth date. So birth date is maps to birth date. The framework is able to understand the fact that in Java we use birth date, and in table typically we use birth underscore date. So in this kind of a scenario, person kind of scenario, you don't really need a RowMapper, but a lot of times your table definitions will be different from how your beans are defined. So in those kind of situations, you need to define RowMappers. The advantage RowMapper provides is now I can use this RowMapper everywhere. So wherever I would need to map this table or this kind of rows, I can use the RowMapper in all those kind of situations. So this specific logic which we are writing in here, we get a little bit of reusability around that by creating a RowMapper. If you go ahead and run, you would see that there is no change in functionality as such. So you would see that the find all would still be able to get all the rows from the database and it would print it to the log. You would see that nothing has changed in that stuff. In this step, we looked at the last important concept in JDBC, that of a RowMapper. Until the next step, bye-bye.